Good afternoon and welcome back to the Workbench. So today I wanted to do a video that continues slightly the automotive theme that I've been, well, not really, but you know, the previous video I talked about my own car and about the manuals that I bought for it recently from Japan. And then this video will continue that kind of with this head unit and speakers which I just replaced in a friend's car. It's a Nissan Pulsar 98. So there's several issues with the whole system there, and I'll go over those. But the first issue that would become apparent, I believe, was with the head unit itself. I think the CD player in it was faulty for quite some time, but my friend had not bothered to do anything about that until the battery in the car started going completely flat, and it turned out this was the radio here that was draining the battery, which is obviously not right. Now this unit here was obviously used in the car for quite some time. It's not the original, but it was used for quite some time, and we had no issue, so it obviously wasn't a wiring issue. The wiring was all done very well when I took it out, so you know, there's no miswiring or anything. I mean, a common mistake people can do is to wire the accessory wire, typically the red one, directly to 12 volt, which means that the thing is never switched off. These head units, in case you don't know, they typically have two power wires. They have a yellow one, which is always on, providing standby power, and then this red one is a switch signal from the ignition key to tell the thing to turn on and off. So when the key is off and taken out of the car and everything, this wire should have no power, and this thing will be in very low power standby mode. If you wire these two together, then the thing will be on all the time and it will drain the battery quite quickly. So yeah, but that wasn't the issue at all. The thing had been working perfectly fine for many years, as far as I know, and just only recently started making the battery go flat. So it's pretty obvious that there's some fault with this. The other fault was that when I replaced the head unit, this one with a new Pioneer one, I don't know what brand this is. Well, it's called a Nitro. I've never heard of this before. Then again, I'm not a car audio specialist, so this might be who knows, it might be a common brand, or was, but I've never heard of it. You know, I've only heard of the big name brands like Pioneer and Sony and Alpine and all that. So yeah. Anyway, so when putting the new head unit in, I checked the speaker resistance on the two wires for the left and right, and the right side was showing about 4 ohms, which is what you expect, because these are 4 ohm speakers, and the left side was just showing open circuit, so there was nothing there. And I kind of came to the conclusion that, well, if the head unit is faulty and it's draining the battery, there's probably a short circuit or something somewhere. And if the left channel speaker is not working and it's showing open circuit, well, possibly the left channel amplifier has gone short circuit, it's burnt out the speaker, and you know, that's how that's happened. Or that's what I thought. On closer inspection, when removing the speakers, I found that both of them are actually still perfectly, well, not perfectly. They both measure 4 ohms. The voice coils are both still intact. There's no damage at all in that regard. But if you have a look at them, you can see that, well, there's something wrong. This hole, where I can stick my finger through, shouldn't be there, obviously, if you know anything about speakers. And you can see the surround material here is all cracking and falling away. So yeah, which is not really surprising for a car made in 1998. I mean, these speakers are going to be like 20 years old or more, and you know, in a car door they're going to see quite extreme variances of temperature. They're going to see a lot of vibration, etc. So yeah, it's no surprise that these things are basically falling apart. And yeah, you can buy, you know, repair kits for speakers and that, but for something like this, I mean, is it really worth it? Not really. I mean, you know, you can buy cheap speakers for probably the same amount of cost that you have to buy a repair kit, and then take the time and energy and all that to do it, and hope you get it right. So yeah, and they're not, you know, not amazing speakers or anything anyway. They're just standard generic speakers from 1998. So who really cares? It just makes more sense to buy new ones. That's what we did. So so those were ones we got here. These are Soundstream 6-inch ones, just basic sort of thing, nothing fancy, nothing amazing, but you know, for just a basic stereo system in a car, you know, perfectly fine. Not not really interested in you know, high power or super high quality or big bass or anything, but you know, these are just standard ones. Got inbuilt tweeters, which is nice, inbuilt crossover and everything. So yeah, I guess it is worth noting that these Soundstream speakers here actually fit practically perfectly into the doors of this car. So the hole, as you can see, is not perfectly round. It's a funny shape because the original speakers had that oval sort of shape, even though they have a round frame. But these new speakers basically fit into the door pretty much perfectly. It's just a matter of getting things aligned correctly and then drilling 4 mounting holes, and then just screwing them in. So the screws that come with it are perfectly acceptable. I guess most 6-inch speakers would fit in the hole. The question is the depth of it shallow enough that it won't foul with the window glass? That's really the biggest issue that you might have. Obviously you could go with bigger speakers, possibly if you had a mounting adapter or something, or some other thing, or if you started to cut some of the door away. But yeah, just to do it as easy as possible, and again, not too worried about having the most amazing speakers or anything. This was perfectly acceptable, so it's quite good. It was very easy to do. Just drill 4 holes and that was it basically. And obviously add the extra wiring for the thing, because the plugs for the original speakers and the connectors for the new ones obviously were completely different. So I just sort of splice those wires on and plug them in, and obviously solder those correctly. Put heat shrink and everything. Do it properly. You don't want to just wrap them on by hand and then just put tape around them or something. You do want to solder them, make sure there's a good connection and everything. So I installed the right channel speaker, the new one, and that was all obviously working fine. There's no issues there. And then of course when I went to install the left channel, you know, we still had an issue. There was no sound there. So the next thing I had to do was figure out what was up with that. So I checked the continuity between the head unit connectors and the speaker connectors in the door on the left side, and discovered that the positive wire was connected just fine. The negative was not going through at all. There was no continuity there. So I had a look at that, and there's a connector on the side of the door by the hinge that has a bolt securing it from the car side into the door. And there's actually a multi-way plug that can be disconnected. I unplugged that and disconnected it, and I measured continuity from the plug inside the door to the speaker terminals and found that was correct. And I checked continuity from the plug, the other side of the plug, to the head unit, and the continuity was there too. So that kind of only leaves that the plug itself maybe having a problem. And looking at the pins in the connector, you could see they were kind of tarnished and oxidized. Nothing major, you know, no corrosion or anything. There's no water ingress or anything into the actual plug. But the pins, you know, being 20 years old, just obviously slowly oxidized over time. And I scraped the side of the pin with a screwdriver blade for a bit until it was a bit more shiny, and then we stuck it back together and it started working. So yeah, it just seems to be a dirty connector in the wiring loom connector between the door and the car chassis. That was all done, and then finally both sides were working, and the new head unit was wired up and everything was working. So yeah, that's the story of that. It's time to look at the actual original head unit and see what's wrong with it. At least that's what I intend to attempt to. So I can get these out of the way because obviously they're not necessary for anything anymore, and then we can have a look at this and try and figure out what's going on. So I want to know, well, let's see, how much current is this thing actually drawing? Is that the problem? And also, well, can we fix it perhaps? Is there any point to that? Not really, but hey, we'll give it a go. Okay, so before I hook it up to my power supply and see what happens, I just want to talk about the wiring quickly. So we've got these 3 what they call pre-outs, so sort of preamp outputs. Just standard connectors here, so line level. So there's a left and right channel, and then we've got a subwoofer output on this thing. So you'd send that off to a separate amplifier if you wanted to have higher power than what this can provide. You know, this is only going to be like, you know, 20 to 40 watts or something for a basic head unit. obviously the speakers that it drives are connected through these wires here. So the front speakers are the grey and the white wires, and the rear speakers are the purple and the green. That's the typical colour code used. Obviously in the black striped ones will be the negative, and the solid wires will be the positive connection. Obviously, that one is a solid green. This is green with a black stripe, so that's the negative. The wiring in the car, however, is typically completely different and makes absolutely no sense. So the easiest way to fix that problem is to buy an adapter harness for whatever car you have, and then connect that to the correct connector. You can either buy ones that do the whole thing for you, but those are kind of expensive. It's cheaper just to buy a plug that fits your car, and then solder that to the plug that comes with your new head unit, assuming you bought that and actually have a plug for it. Anyway, so that's that. So if you're using the internal amplifier, you connect your speakers directly to this. This is not a 4-channel amp or surround sound or anything, so the rear speakers are just a copy of the front speakers. So the signal is all exactly the same. There's no multi-channel decoding or anything. Anyway, so there's the power wires here. So these are the ones that people obviously get confused with sometimes, as I said. So this yellow wire is the always on 12-volt connection. So this, when this wire here has no power on it, this should not draw any current at all. In fact, the general rule for cars, as far as I can see, is that you want a system draw of everything in total of 50 milliamps or less when the car is switched off, which is obviously not very much, and that makes sense. If it was any higher than that, then you risk the battery going flat far too quickly. So yeah, so we got power, main power here, and obviously ground is the black wire, so that's these two there, and then the red, that's the signal from the ignition switch to tell the radio that it actually can power up and come out of standby. And then we got these three here. Now the blue one is typically the what they call the remote wire. So this sends a power up signal to other systems, other components like a separate amplifier or antenna amplifier, or some other kind of system, other attachment. This is not designed for supplying power. It's just designed to supply a signal, just in the same way that the red wire receives a signal from the ignition key. This should send a signal to other stuff to help to power up, and then they'll get their own power feed separately from another wire like that. The orange one is the often called the illumination wire, which is kind of confusing. Basically what this does is it takes a signal from the headlight switch. So when the headlights are turned on, this receives a signal and will dim the display on the radio. So you don't get this super bright display at night blinding you from your dashboard. And this red wire, well, I'm not entirely certain. There's no indication on the back of the head unit as to what this wire does, and I can't remember if there's anything specific about it. It might be a input wire for, say, a remote control button you can attach to your steering wheel or something. But yeah, I'm not certain about that. The one we're concerned about at the moment is just these two here, so the main power and the ground. So what I want to do is just take these crimp connectors off, because obviously we don't need those anymore. I'm just going to strip these and connect them to my power supply. So if we can get that in here, so switch this on, set it to the 300 milliamp range, and well, I'm going to have to get that over here, so put that into that terminal there. Looks a bit confusing because that's yellow and this wire is yellow and that's red, but that's irrelevant because this is that's the ground wire actually. This is a positive negative split rail supply, so I'm not miswiring it at all. Now where's the hole in the side of that? There we go, so that's the negative. There we go, so I got that plugged in there. So set this to about 13 volts or so, so that's across these. Got got the current, limit to 150 milliamps. It shouldn't be anywhere higher than that. And if I switch this on, yeah, look at that. It's drawing, over 300 milliamps. If we put it up to the 3 amp range, not sure if you can see that with the angle on here, but yeah, the amount of current that's taking is definitely too high. So this should not be drawing that amount of current at all. Again, put this back to the yeah, okay, there we go. So it's about 250 milliamps. So that is yeah, it's about 5 times the maximum allowable standby current. So yeah, it's definitely something wrong with this. Should not be drawing that much current at all. Even if I ground the input wire, it doesn't matter if this is floating. If I ground this, it shouldn't make any difference. Yeah. So I ground that, nothing changes. It shouldn't matter. This can be open circuit. If I put that on there, obviously it goes up because now it's trying to switch on. But to ground that, I'll leave it open. This should be lower. This should be down. This should be like 10 milliamps or something. So yeah, that's way too high. If I switch over to 3 amp range and plug this in, how much does it draw there? So now we're getting about 500 milliamps with that plugged in. That's with the system powered up. If I turn it on, obviously we get more current here. System is actually up. You can see that there. The thing is now powered on. But yeah, obviously there's no speakers connected or anything. But yeah, that's about. It's gone up to about 700, 800 milliamps there. Which makes sense. It's not doing anything appreciable. But yeah, in standby mode, that should be a lot less than what it is. So yeah, it's yeah, 250. That's clearly far too high. Okay, so even though this thing didn't blow the speaker as I had originally thought it might have, obviously the speaker just had that bad connection in the door. I still want to check this thing here to see if there's any appreciable offset voltage at the speaker terminal, see if there's anything funny going on there. So first of all, let's just check these. These really shouldn't be more than a couple of millivolts or something. So let's just see what we get here. DC, so that's 10 millivolts DC on there, so that's pretty low. On this one, we've got 3 millivolts. That's a bit better. See if I can probe the rear. I haven't got that here. The rear one. Okay, that's like 18 for that one. It's not amazing. And this one is 8. Yeah, 18 is kind of high, but it's not, excessive. Just open this thing up and you can see there's not particularly great quality. There's service mount components here that have been redone by hand, like this transistor there. You go over here, this little circuit there, after that's all been reworked or something. It's quite funny, this just regulator or transistor or whatever, looks like it's been had some hand work done on there and some other parts. This resistor over here has definitely been had something done to it. And the best one is this switch here, well, this LED actually. You can see the pins there are barely even soldered on. The solder only goes on the front side of those pads, and on the back there's absolutely nothing there. So yeah, not the best quality at all. It looks like, I guess, they've done like oven reflow or something on all the surface mount parts, and then done all the through-hole stuff by hand, I guess. But yeah, interesting. This thing doesn't even show up online anywhere. Google. Nitro does seem to be a known brand, but this particular model, BMWX-9903, there's nothing whatsoever for that. So I have no idea if this is a knockoff or what, or it's just one of those models that inexplicably the manufacturer never bothers to admit they actually made. I've definitely seen that happen. But But yeah, there's not a lot to it on the bottom here. We've got an STC, I think, microcontroller, probably doing all the main functions, and then we got, I'm not sure what this is exactly, have to look it up later. A few regulators and things. What is that? I don't know. No idea. Probably a custom ASIC driver for the VFD or something. Most likely. Anyway, if you look on the other side, so I've taken the CD drive out, so that's that there. So that just unplugs with this ribbon cable. So that's obviously all the CD stuff in there. And inside is pretty bare once you take that out. We've got a sort of riser board connector thing at the back for all the connectors. Looks like possibly a filter capacitor and some sort of coil for this here, which is obviously the power amplifier IC. I don't know what this is. It's got a small crystal on it, so it's probably like a clock module of some kind. Then we got under this, I think, is some sort of boost converter, and then we got a transistor. I don't know what that is. Might be a power transistor, some sort of linear regulator maybe, or something. Yeah, a few little 3-pin devices. This LED switch stuff here, and this wiring that goes to the front panel. To these lights and this connector, obviously, for that. So it's pretty sparse inside. Once you get that off, obviously the most complicated part is the CD drive. But yeah, I mean, they've obviously used this horrible glue here, as you can see. It's gone a bit crusty over time, which could be part of the problem. I mean, who knows if that's contacting any of these wires and it's causing you know, some kind of electrical leakage there. It could be causing that current draw. I mean, yeah, well, there could just be a fault with the circuit. So yeah, I mean, that's taken the faceplate off and the CD drive out. So might be interesting just to plug it in and see how it goes as it is just now, and see what kind of current it draws with those two disconnected. It does seem to be kind of low quality. We've got this thing here, KF7602X mainboard, I guess, from Rev 2.0 from 2008. I don't know KF. No idea if that's you know, it's because it'd be a rebranded thing or something else. No idea. I'll look that up later and see if I can find anything, because obviously the this part number, as I said, comes up with absolutely nothing. Okay, so like I said, I got this plugged in with just this main board here connected, so we'll turn it on and see what happens. There we go. So look at that. We've only got about yeah, 20 milliamps or something, which is more like what I'd expect. So that's interesting. We're not getting that high current. It would be 250 before, now it's only like 25, so that's interesting. So I wonder if the fault is with the front panel or with the CD. Now we know the CD drive doesn't actually work, so I mean, you can put a CD in but it won't read it, so possibly, I wonder if that is the issue. So let's try turning this off again. I'll just plug in the front panel just to see if that makes any difference. So that goes on here like this. No, hang on. It goes on this end first. That slots in there. So that goes on there like that. Let's see what we get now with that plugged on. Okay, we get a brief burst of current, but it is falling back down to about 20-25 milliamps once again. So that's interesting. So it looks like there's some issue with the CD drive, and that it's drawing more current. I mean, this is definitely much lower and much more like what you'd expect from something like this. So yeah, I wonder if whatever fault is with the CD drive that it can't read discs is also the fault of why it's drawing too much current. Let's just take a quick look at this. There's nothing obvious. obviously burnt or anything. The only kind of visible issue is this IC, which you think could have popped, but that's just flux residue from where they've manually soldered these ground tabs, heatsink tabs. So yeah, could be anything really. Looks like some memory, main control chip, some kind of EEPROM. I guess the motor drive or laser driver or something, or amplifier. Crystal, and probably a couple of voltage regulators or MOSFETs for switching the motors on and off or something. What's that there? Q2. That's IC. So there's probably 2 voltage regulators there. That might be a little switching transistor to switch the load, tray load, drive on and off, that kind of thing. A couple of diodes over here. That looks like the connection to the motor, or one of them. Yeah. Well, I guess troubleshooting this part is probably not that easy, and also not really that much point. When you think about it, I mean, it's not like using this head unit is really necessary. Yeah, I mean, we've got a few ceramic caps here. If one of those was possibly a bit shorted, or something, that could be a problem. Ceramic caps do tend to like to go shorted occasionally, so who knows if possibly there could be some issue like that. Shorted capacitor, and it's just pulling the voltage down on one of these regulators or something. I mean, if you actually look at the board here, I kind of wonder, this one seems to be, I don't know if this is the camera or something, but I just wonder if the board around this one seems to be a bit kind of darker. I don't know, interesting. Maybe this one's been running a bit hot, so you could look at the thing. I mean, hell, even that capacitor right next to it, what if that was leaky? Could be the problem or something. Might be pulling that rail down, and then maybe there's not enough voltage to drive the laser properly, that sort of thing, and that's why it won't read the disc. Who knows? But yeah, I might have a quick look at that if I can, but otherwise, I mean, nothing really much to say. It's not worth sort of repairing really, but it might be worthwhile scavenging that amplifier chip out of this or something, possibly, or even just this thing's got an auxiliary input, so you could even just take this out, leave it out, and just use this as a little stereo amplifier module with an auxiliary input, and just use it for that. And it's got a radio as well if you want to be bothered hooking that up. But yeah, who knows? I'll see if I can find anything obvious with this, but as it stands, I guess there is some kind of fault with this thing, causing it to draw too much power. I mean, you could say, well, we don't know what the actual spec is for this. Maybe it's supposed to draw that much power on standby. Well, I doubt it. I really doubt it. And besides, this CD drive shouldn't even be active when this thing is in standby at all. I mean, this should only be working when the thing's set to CD mode and it's actually powered up. So, I mean, this thing should not take 250 milliamps in standby when it's not even reading a disc or anything. It doesn't even make sense. So there's definitely going to be a fault in this module. I'm sure of it. It has to be. It's not logical otherwise. Either that or it's an incredibly bad design. Well, I plugged this back in and had a look at this, and this regulator here is definitely getting quite warm. This is a 3.3 volt regulator. It's a standard, I think, 1117 compatible part. It's labelled as EH16A, which is the standard 3.3 volt LDO, so that's taking 12 volts, I guess, from the input, and stepping that down to 3.3. It's getting quite warm. If I leave it on, you can definitely feel it. So yeah, that discoloration on the board is definitely there, so it's from the heat output of that. So yeah, so we got, I guess, about 250, 220 milliamps being drawn through this regulator here on that 3.3 volt rail. It is supplying 3.3, so it's not a dead short or anything, and the regulator is obviously okay. So there's something this is supplying power to that's obviously faulty, I guess. It's not the laser assembly because I've unplugged that there. I don't know what it could be. I'd love to have a thermal imaging camera here just to have a look at various things, but there's not really anything obvious. With my finger I can only really test this and say this regulator is getting quite hot. This one here is marginally warm, that's a 1.8 volt one. Well, this area is pretty much cold. That's cold. It's cold. So this chip here is warm, this is warm, this is pretty hot. But there's nothing obvious here. It could be the problem, so I don't know what to say about that. I guess the only other option is to try putting alcohol on it and seeing where it evaporates. And who knows, maybe this IC has in fact gone bad. I mean, it shouldn't, if it's in standby, it probably shouldn't be running with enough current to actually warm it up. Maybe that's it. Maybe this is where we stop. There's something probably wrong, leaky or partially shorted on this CD drive control board. I don't think I can easily find out what it is. And if it is that main chip, well, again, that's really not worth doing anything with. I mean, hey, you could probably buy them on eBay or something, but, you know, probably like $20 or something, and then, you know, why? There would be no point. For all we know, the laser's bad. Something else is bad, I mean, yeah. Oh well, just for fun, let's do a demonstration of the alcohol troubleshooting technique in action. So I've just dipped some alcohol on the board. If I just turn the supply on, we see this regulator here heats up pretty quickly, starts drying off, and we can also see the center of this main IC also starts to dry off fairly quickly. So yeah, the track connected to this is now drying, whole regulator here is drying, but everything else seems to be still pretty wet. So yeah, I mean, this stuff was all cold to the touch anyway. This regulator's drying off a little bit. This one is definitely getting quite warm, and so is that. So nothing else obviously seems to be getting hot. Camera isn't very good at showing this up. Unfortunately, with the eye, it's pretty obvious that it's just this chip, and these regulators, and especially this one, is definitely getting quite warm. So I mean, this thing is supposed to be in standby mode. It shouldn't be drawing this much current, and this is the only thing getting hot, and this, who knows, maybe that is in fact the fault. Again, worth replacing? Not really. Could you replace it? Well, probably. Even if you could find this chip for a decent price. I mean, yeah, there's not really any point to it. For something this this generic and basic and cheap, it's just no point. So who knows? Maybe I will just scrap the CD unit out of this and repurpose it as some kind of little stereo amplifier with the auxiliary input, FM radio, that kind of thing. I mean, who knows? Not really any. I don't really need it for anything, but you know, I could do that, I guess. Could use it as a workbench amplifier, testing things. That could be quite useful. So there we go. Probably not likely to be repairable because you probably can't get that chip anyway. And even if you could, well, wouldn't really be worth it. There'd be not much point. So I'm thinking that's probably about it for this one. I might repurpose it and use it as some kind of generic amplifier or something, maybe, if I can. But other than that, that's it for this one. Sorry it couldn't be a repair video, but hey, just the way things go sometimes. So anyway, hopefully that was interesting. Hopefully that was useful to someone, and I guess I'll see you next time.